The video help for problem 4.5. We learned in chapter 3 that if we were talking about some reference frame that was being rotated by an angular velocity omega, that we could write any time derivative as a time derivative relative to that reference frame plus omega cross m. So in fact, if something were at rest in that rotating reference frame, this would give the complete time dependence, the rotation. Well, what we'd like to do is have this rotation be in the same direction, match the precession direction for our external B field and our B0. And so we'll have minus omega z hat, because we're not going to put this as omega 0. If we put omega 0, we would match the precession exactly, but we might be offset a little bit. So we'll have an offset delta omega from that. And I'll rewrite this cross product then with this minus sign converted into a plus sign by doing m cross omega z hat. Now, what I'm going to do is essentially just solve for this. I'll have to write dm dt. In the laboratory, remember we had precession, we had longitudinal recovery, and we had transverse decay. And the key is now, I want to put everything in terms of the rotating unit vectors. That is, dm dt prime will be equal to this, and then minus this, bringing this to the other side. So I'll get a bunch of stuff there, but before I do that, let me just say, a very important thing. We have a vector, say, in the lab frame. We can write this in terms of the rotating reference frame. We can have it relative to any reference frame we like. These will be the x hat prime, y hat prime, z hat prime. These are, of course, rotating in the laboratory, but that's okay. But if we go to this reference frame and we're interested then in looking at it relative to this reference frame, we want to get everything in terms of those unit vectors. So take all of this stuff. I just am taking this with this moved over to the left side, and I get, I get the precession. I get this from the rotating term here. I can swallow this up with the omega 0 part. Remember, our magnetic field is really the static main magnetic field plus the RF pulse. The RF pulse is already in the x hat prime direction. It's rotating, so that's a perfect, that's really a nice clean result. That's most naturally written when we write it in terms of the rotating reference frame. Well, I can just rewrite then the B0 and swallow it up with the omega and remember what delta omega, that offset is, 1 over gamma that, plus the B1 x hat prime. And anything else I want to tell you about this? I think that all of this then is going to be clear when all you need to do now is consider everything relative to the rotating reference frame. In other words, you'll replace everywhere what you'll have. You'll replace x hat by x hat prime, which means, what means is that you'll have, instead of mx, you'll have mx prime, the component relative to that. Any vector you have, you can rewrite it in terms of that new reference frame. And the thing that's neat is that in this reference frame, that time derivative, I get no derivatives of x hat prime, because in that reference frame, x hat prime is constant. So this derivative is just dmx prime dt times x hat prime. No time derivative of that, if you remember that from previous homework. Plus, the my prime and the mz prime. Well, do the cross product and equate the x prime, the y prime, z prime guys. In other words, all the, look at all the x hat prime terms. They all have to cancel each other from the left side and the right side, and so forth. And remember, omega 1 is gamma B1.